So far we've looked at solving some basic trig equations, so now let's look at a few more and a few other techniques. Let's solve 2 times sine of 3x minus 1 equals 0 for x between 0 and 2 pi. So the first thing we notice is that we have a restriction that we're only giving answers between 0 and 2 pi. How is this different from the other ones we've solved so far? Well, you probably noticed the argument is not just sine of x, it's sine of 3x. And we've learned before from our graphing that what happens with that is that our period is going to change, and instead of being 2 pi, now the period is 2 pi over 3. Or in other words, we have, let me draw an arrow. In other words, we get one complete cycle of the sine graph from 0 to 2 pi over 3. So from 0 to 2 pi, we're actually going to get 3 full cycles of our graph. And so that's going to change the number of answers we're going to get. So let's go ahead and solve this like we did before. So I'm going to add 1 to both sides and then divide by 2. And we're going to get the sine of 3x equals 1/2. Now, we think back to the unit circle and say, well, when is the sine equal to 1/2? Well, that occurs at 2 different spots. The sine is equal to 1/2 at 30 degrees, or pi over 6. And then it's also equal to positive 1/2 at 5 pi over 6, or 150 degrees. So those are the 2 spots. But instead of just saying x equals pi over 6 or 5 pi over 6, now we're saying the argument, which is 3x, is equal to pi over 6 or 5 pi over 6. But now I'm going to do something different. As if we didn't have any restriction on where our answers were going to be, we would normally then say it's pi over 6 plus 2 pi n. Now why am I adding 2 pi n? Well, remember, the period is changing. So let me write the other possibility. 3x is equal to 5 pi over 6 plus 2 pi n. Now I'm trying to solve for x, so if I divide everything by 3, I'm going to get x is equal to pi over 18 plus 2 pi over 3n. And here I'll get x is equal to 5 pi over 18 plus 2 pi over 3n, where n is any integer. Now, what I need to do is figure out all our possibilities. So we're going to have x is equal to pi over 18 if n is 0. If n is 1, I'm going to add, let me just write this out, I'm going to add 2 pi over 3 to that. Well, I can't add those fractions unless I have a common denominator. So if I multiply top and bottom by 6 over 6, I'll get 12 pi over 18. So when I'm adding 2 pi over 3n, I'm changing my fraction to be 12 pi over 18n. So keep that in mind as I come up with my next solutions. So when I add 12 pi over 18 to pi over 18, I'll get 13 pi over 18. Notice that's still less than 2 pi. 2 pi would be 36 pi over 18. So I'm just going to keep going. I'm going to add another 2 pi over 3, or 12 pi over 18, and I get 25 pi over 18. That's still less than 2 pi. If I add another 12 pi over 18, I get 37 pi over 18, and that's too much. That's greater than 2 pi, so I should stop here at 25 pi over 18. So I'm actually getting 3 answers for this first pi over 6. So instead of just the pi over 6, well, divided by 3, I'm getting 2 other answers as well. And that's because from 0 to 2 pi, this function goes through 3 full periods. So where I'm going to hit that value, 1/2, 3 times. Now for the other solution, 5 pi over 18, the same thing occurs. So I've got 5 pi over 18. And then if I add 2 pi over 3 to that, or 12 pi over 18 to that, I'm going to get 17 pi over 18. And if I add another 2/3 pi, or 12 pi over 18, I'll get 29 pi over 18. That's still less than 2 pi. And if I added one more 12 pi over, then I'd have 41 pi over 18. And that's bigger than 2 pi, so I was supposed to stop. So notice all of my answers here are less than 2 pi. And that's what was required between 0 and 2 pi. So I've actually got 6 answers, where normally if this was just sine of x equals 1/2, I'd have 2 answers. Now it's 3x, so I wind up getting 3 times as many answers, 6 answers. Let me show you on the calculator to make a little more sense of it. So if I graph sine of 3x, and let's zoom trig. Let me change my window a little bit here. Let's go, so let's go, how about negative 0.1 and max 2 pi. And we'll leave that alone, and then we'll go negative 2 to 2. Okay. So that's the graph of sine of 3x between 0 and 2 pi. Let me also graph y equal 1/2, the constant. You can see that my sine graph intersects y equals 1/2 at 6 different spots. And if I hit trace and I start typing in my answers, the first one was pi divided by 18. You can see that's where those two graphs intersect. If I go to the next one, which is 13 pi over 18, it's not going to be the next one in my graph on the downslope, but it'll be the next upslope. So 13 pi over 18, it's that next one on the way up. And then if I jump over to the last bump on the way up, that should be 25 pi over 18. And sure enough. So those were my first 3 solutions for that 3x equals pi over 6. Now I'm going to go to my other solutions. 5 pi over 18, just to show you. That was on the way down of the first bump. 17 pi over 18. That's 1 full period away. And then the last one, which was, what, 29 pi over 18? And there you go. So that's why we get 6 solutions, because sine of 3x from 0 to 2 pi goes through 3 full periods. So not just the 2 answers, but the 2 answers 3 times, because of the period going 3 times from 0 to 2 pi. All right. What other types of equations? How about this one? Let's solve 2 plus tan of x over 2 equal 1. Now this is going to be the same idea. So I'm going to subtract the 2 to the other side, and I'm going to get tangent of x over 2. 1 minus 2 is negative 1. And so now I think back to my unit circle, and when is the tangent equal to negative 1? Well, that's when the sine and the cosine have the same values. That's the pi over 4 reference angles. But here the tangent is positive in the first and the third quadrant, because the sine and cosine have the same sign. But it's in the second and the fourth quadrant, so 3 pi over 4. And down here at 7 pi over 4. Now, this did not give us any restrictions. So unlike the first one where it said x is between 0 and 2 pi, we have no restrictions, so we have to keep that in mind. So when is the tangent equal to negative 1? So the argument, or the angle, must equal 3 pi over 4 plus, now what's the period of tangent? The period of tangent is just pi. So pi times n. So notice from 3 pi over 4 to 7 pi over 4, that's exactly half a circle away, or half of 2 pi, so pi units away. So we have x over 2 is equal to 3 pi over 4 plus pi n, and now we want to solve for x. And we're going to get x equals 3 pi over 2, because I'm multiplying everything by 2, plus 2 pi n. Notice the normal period for the tangent function is pi. If I divide that by the coefficient of x, which is 1/2, that gives me 2 pi. So the new period is 2 pi instead of pi. So here's my solution. And if you want, you can go ahead and graph, draw an arrow. If you graph this function, tangent of x over 2, and you look to see when it equals -1, it's going to be at 3 pi over 2, and then every 2 pi after that, or before that if n is negative. All right, let's take a look at a different type of problem. And we've done something like this before. When we look at this, we have 3 terms. It looks like a trinomial or a quadratic. And so, if you're still having trouble looking at that as a quadratic, think of it as 6a squared minus a minus 2 equals 0. Can you factor that? Well, I think we can. And that would be 3 cosine, let's try that, 3 cosine of x times 2 cosine of x. That would give us 6 cosine squared. And then if I put a 2 here and a 1 here, make the 2 negative and the 1 positive, then when I do these two, I'm going to get a -4 cosine, and those two gives me a positive 3 cosine, which would add up to a -1 cosine. So, and when I multiply -2 times 1, -2 times +1, I get a -2. Okay, so we factored this correctly. So now we're going to set each of these factors to 0. So I have 3 cosine x minus 2 equals 0. And 2 cosine x plus 1 equals 0. Now I'm going to solve the second equation first. If I subtract the 1, and then I divide by 2, I get cosine of x equals -1/2. Notice also we have restriction here. We're just looking 0 to 360. So if I think my unit circle, when is the cosine equal to -1/2? That's the x value, so that's going to happen up here and down here. And that was the 2 pi over 3, or 120 degrees. And then 240 degrees, since our answer should be in degrees on this. So that gives us our first answers. X is equal to 120 or 240. But what about this other equation? When I solve that, I'm going to get cosine of x equals 2/3. And 2/3 is not on my unit circle. I don't have a coordinate 2/3 comma something. So I'm not sure exactly what that angle is from the unit circle. So how do I solve this? Well, I'm going to have to use the inverse cosine function to help me figure this out. Now we have to go back and think about, what do we remember about the inverse trig functions? Remember, the inverse cosine gave us answers between 0 and 180, or 0 and pi. So it's just going to give us values here. So when I do inverse cosine of 2/3, I'm not going to get both of these answers. I'm just going to get this answer here. So let's grab the calculator and see what it gives us. Let's switch to degree mode. And then let's do inverse cosine of 2 divided by 3. 48, we'll say 48.2 degrees. So this is 48.2 degrees. So let's move my arrow. So what's this one down here? Well, if this point is 48.2 degrees up from 0, then this one's going to be 48.2 degrees down from 0, or down from 360. So if I subtract 48.2 from 360 degrees, that'll give me this angle. I don't want to get a negative angle for an answer because I'm supposed to be giving answers between 0 and 360. So I want to know if that's 48.2 and I kept going, 180, 270, how much would that be? So all I'm going to do is take 360 minus 48.2, and that's going to give me what? 311.8? 50, I believe so. So 311.8 degrees. And so there I have my other two answers for x. So because this wasn't on the unit circle, I'll write these in here first. 311.8. Okay. Because this value here wasn't on the unit circle, all the other equations we've solved so far, they've always been a half or root 3 over 2 or for tangent 1, etc. But for 2/3, now I can't reference my unit circle. So I'm going to have to use an inverse trig function, which remember, just takes a part of the cosine graph in order to make an inverse. And so it's only going to give me one of the answers. So for inverse cosine, it gives an answer between 0 and pi, or 0 and 180. If this happened to be a sine equation and we had to use inverse sine gives us answers from pi over 2 to negative pi over 2. So we'll have to take that into account as well. All right, and once again, you can always graph this in y1 and find the x-intercepts and check your answers to see if these work. I won't go ahead and do that, but I'll leave that up to you. All right, let's solve one more equation. And here we're going to have to use, and notice there were restrictions on that one, no restrictions on this one. So we're going to have to do plus 2 pi n. All right, when does the sine equal 1/3? Well, once again, that's not a value from the unit circle, so I can't use that as a reference. So I'm going to have to figure out using the inverse sine function. So x is equal to inverse sine of 1/3. Now this one's in radians. It's a little easier to think of things in terms of degrees, so maybe I'll start with degrees just to help you out, and then I'll switch it to radians. So if I do inverse sine of 1/3, right now I'm in degree mode. Second sine 1 divided by 3. I get about 19.5 degrees, so I'll say 19.5. So 19.5 degrees. Put that in parentheses. Now let me go back and calculate it in radians. Mode, switch to radians, press second enter. So let's go 3 decimals, so 0.3398, so 0.340, 0.340. And that's in radians. Okay, so, and then plus 2 pi n. So that's my first answer. Now we've got to figure out the next answer. Now, 19.5 degrees, that's somewhere over, let's say, about here. So I've got a point here. So that's where the sine is equal to 1/3. I'm going to write 19.5 degrees. I also know that the sine will be equal to that over at this spot, across from it. The sine there will also be 1/3, because these 2 points have the same y value, and the sine is the y value. It's the opposite over the hypotenuse, and in the unit circle, the hypotenuse is 1. So this same y value of 1/3, now let's just put that right there, 1/3. So I know that I'm supposed to have 2 answers here. The calculator using inverse sine only gave me this answer. So how do I get this answer? Well, I know they're both up the same number of degrees from the x-axis. So how could I find this one? Well, right here is how many degrees? 180 degrees. So if I subtract 19.5 degrees from that, I'll get this angle. So if I subtract 19.5 degrees from 180, I get what, 160.5? So 160.5 degrees is my other answer. Now what is that in terms of, how do I do it in terms of radians? Well, in radians, this was 0.34. And so how am I going to get it on the other side? Well, instead of 180 minus the angle in degrees, I'll do pi minus 0.340. So I'll grab my calculator, and I'm just going to hit second pi minus second answer, 2.80. 2.801, 0.802, 2.802. So let me write that, 2.802. So that's going to be my other answer, 2.802 plus 2 pi n. And there we have our two answers. And I'll show you very quickly on the calculator just to get a visual for what's going on. So I'm going to graph sine of x. And then down here, I'll graph 1/3. Notice there's two answers there. If I press, I can hit trace and type in my decimal, or I can do second calculate. Number 5, intersection is the first curve y1, press enter for yes. Is the second curve y2, yes. Give me a guess. Let's move over to the first one we got here. And that's close enough. And notice we get 0.3398, which we rounded to 0.340. And then if I do that again, second calculate 5, first curve y1, second curve y2. Give me a guess. I'm going to move that over quickly. And we get 2.8017, which we rounded to 2.802. And notice that's going to keep happening then as we go through every period of this graph. So if you keep adding 2 pi to those answers, you'll get all the other answers as well. All right, so a lot more thinking involved in solving these equations. We have to go beyond the points that we know from the unit circle. And so it takes a little bit of time. So there's not as many homework problems, but you need to really think through the process as you're working on.